Okay, hello mathematicians. Today we're going to do chapter 8, lesson 5, which is on the least common multiple. So we've already talked about the greatest common factor. Now we're going to talk about the least common multiple. So factors are the numbers we multiply together to get a product, to get a multiplication answer. A multiple is basically when kind of like skip counting, or when we say like what are your threes, and you go through and you say 3, 6, 9, 12, 15. So when you think about the word multiple, you can think skip counting. Okay, you can think about skip counting. So basically going down your list, maybe on your multiplication chart of your fours, and you go down the list and you go 4, 8, 12, 16, 20, 24, 28, 32, and you go down all of your fours. So if we talked about multiples of 6, right, and we were asked to list them, so we would think, okay, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36, and on and on and on. And there are a countless number of multiples because of 6, because I could do 6 times a million. 6 million is a multiple of 6. I can multiply 6 times any number and get a multiple of 6. So multiples go on forever, where factors are limited, right? There are only certain numbers I can multiply together to make a 6, but I can multiply this 6 by anything to get multiples of 6. So when we're looking for the least common multiple, we're looking for the smallest number that two numbers have in common. So if I listed, there's the multiples of 6. If I also listed the multiples of 4, right, then I would say, okay, there's 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, 4 times 8 is 32, 4 times 9 is 36. So we can see that 4 and 6 actually have a lot of common multiples. They have 12 as a common multiple, they have 24 as a common multiple, and they have 36 as a common multiple. But I want the least common multiple, so the smallest of the common multiples. So the least common multiple, which we abbreviate as LCM, of 4 and 6 equals 12, right? That is the smallest number that they have in common. Okay, let's look at the example on 577. It says Tom hits golf balls at the driving range every 3 days, practices putting every 4 days, and goes golfing every 6 days. If he does all 3 activities, in how many days will he do all 3 activities again? So if he did all 3 activities today, when will he do all 3 again? So all 3 on the same day. So that means I need to find multiples of 3, because he goes to the driving range every 3 days. We have to find multiples of 4 because he goes to the putting. He does the putting every 4 days, and then he actually goes for a round of golf every 6 days. So we're looking for the least common multiple of these 3 numbers. So first I have to list the multiples of 3. So I would say there's 3, 6, 9, 12, 15, 18, 21, 24, 27, and I'm going to stop there. The thing about listing multiples is you're not always sure where you should stop. Sometimes you have to come back to it if you didn't go far enough. So let's do 4. We have 4. 8, 12, 16, 20, 24, 28, 32, and I already have some in common between 3 and 4, and now I need to just make sure that 6 also has those in common. I can see there's 12 in common, there's 24 in common, and so now when I'm looking at this 6, I'm hoping, and maybe I already know if I'm good with my multiplication facts, I already know what it's going to be, but I'm going to list them 6, 12. Now, do I need to continue going on? Because I'm looking for the least common multiple. So the smallest one, that's the first one I find. So the first one that all 3 of these numbers have is 12. So the least common multiple of 3, 4, and 6 equals 12. So on the 12th, I don't want to write the word 12, on the 12th day, Tom will do all 3. Right, it is a word problem, and so I have to have words in my answers. So on the 12th day, Tom will do all 3. Now, I could also do this. Yesterday, I showed you the ladder method. I can also do this using the ladder or doing factor trees. I like the ladder. So if I was going to do this with the ladder, I would put 3 in my ladder, 4 in my ladder, and 6 in my ladder. Well, this one doesn't work this way. Actually, this one doesn't work for the ladder because I got 2 prime numbers in there, so it's actually not going to work. So we won't do the ladder on that one. I'll show you the ladder on when that works. All right, the next example 2 wants to find the least common multiple. Find the LCM of 15 and 40. So to do this one, this is the factor tree version. So I would do 15. The factors of 15 are 3 and 5. Both of those are prime, so I would circle those. And the prime factors of 40, I would do 2 times 20. 2 is prime. 20 is 5 times 4. 5 is prime. And 2, somewhere on the bottom of my page there, and 2. So then what I'm going to do is this time for the least common multiple, I have to multiply everything that I circled. But if they are in common, I'm only going to multiply them once. So first I have to see what they have in common. So they have a 5 in common. So I'm going to write that down. 5 times. That's all they have in common. So I only write the 5 once because they have it in common. Then I'm going to write down every other factor. So I'm going to write down the 3 times, and I have 2 times 2 times 2, right? So 2 times 2 times 2. So the least common multiple of 15 and 40, you have to do the math here. So 5 times 3 is 15, and then I have times 2 times 2 times 2. 15 times 2 is 30 times 2 times 2. 30 times 2 is 60 times 2 is 120. So the LCM of 15 and 40 is 120. Okay, so when they have it in common, I only write it one time. This is a great one for the ladder. So on the ladder, I would put 15 and 40 in the ladder. And I would go, okay, what do they have in common? I can divide both by a 5. And 15 divided by 5 is 3, and 40 divided by 5 is 8. Now what I would do is I would multiply everything on the outside that makes an L. So around the whole outside. So I would do 5 times 3 times 8. And I'm actually going to use my commutative property, and I'm going to change that around. I'm going to do 5 times 8 times 3. I'm going to use my commutative property. And here I have 40, and then times 3 comes down, and 40 times 3, 4 times 3 is 12, is 120. So then the LCM of 15 and 40 equals 120. So if I use the ladder, I take everything on the outside of that upside down division to get my least common multiple. And just a side note, if 15/40 was a fraction, 3/8 would be my simplified fraction, right? So I can use that ladder for both LCM and for least common multiple and for simplifying fractions. All right, have a good day. I hope this was helpful.